Welcome back. Here it is, your favorite math YouTube channel, Husky Math, or whatever else I rename it later in the future. We are going through the final review for IM3 Spring Final, and I've already covered the first couple of problems in another video about dividing and factoring and all that good stuff. And those were nice. And we have some more factoring. These are classic quadratics and also some cubics. So let's have a look. You're supposed to be familiar with the basic difference of squares idea. So if you have two squares that are being subtracted, then you already know how to factor. Okay, you do not have to do the X box. You don't have to do any of those things. You already are supposed to know the pattern. You take the square root of both of them and you put a plus and a minus between them and put that in parentheses, and then you're done. And you don't have to do any other thinking. So here we take, let's try to color code this. We'll take the square root of this, and that's going to be 5x. And then we'll take the square root of this, which is 4. Okay, and we're going to put parentheses around this and give it a plus, and do the same thing and give it a minus, and those same values again, 5x and 4, and we're done. And that's all it is. No thinking, no math, really, just the square root taking, and that's it. So there you go. Number 6, again, if you would like, I would recommend looking up the rule for cubes and then pausing the video. And here we go. So actually, I need to restate the rule for cubes for you. So the way it goes is if you have the sum of cubes, if you have some cube plus another cube, then what it is, it's the cube root of the first one plus the cube root of the second one. And then you times it, and then you take those two values and you square the first one, and you square the second one, and put that on the end. And here you change the sign. That's the weird part. You multiply both of them, and there you go. But there's no 2 there in front of the AB. And that's how the pattern goes. So for us here, we can cube root 27x cubed. So that's 3x. And we can cube root 125, and that's 5. So that gives us our first binomial. And then you square the first one, you get 9x squared. Then you multiply both of them, but you change the sign first, so you get minus 15x. And then you square the second one, and you get plus 25. And that's it. That's all you do. You just follow the pattern. Try it on number 7, but this one is the difference of cubes. So for this one, same thing. Cube root of the first one, 2x. Cube root of the second one, 3. Same sign. Square that first term. Change the sign here. Multiply the 2. And add the square of the other one. So very similar. The difference of cubes and the sum of cubes, very similar. Try this one, pause it if you like, and we're back. 2, so here, this one's a little bit weird because, well, you can factor out a 2. And so because you can, I suggest you do so. If you can factor anything out, factor it out. So this then becomes 2 times m cubed minus 1, doesn't it? And m cubed minus 1 is just the difference of cubes, just as before. So we take the cube root of the first, and the cube root of the second, we keep that sign, then we square the first one, we change the sign here, we multiply both of them together, and we add the square of the last one, and we're done. Follow the pattern, my friends. Follow the pattern. Number 9. So this one is division, and there's a couple different methods that we use. So why don't you try your favorite method, and we'll be right back. Okay, I hope that was good. You could always pause it if you need more time. So there's a lot of different methods we can use. If the coefficients and the leading variables are just one, I always feel like synthetic division is the easiest. So I'm going to start with that. And so what that looks like is essentially that the coefficients here, 1, 11, 16, -4. You just write those in here. 1, 11, 16, -4. And you take the 0 of the divisor. So here, the 0 is -1. So if I was to say a plus 1 equals 0, and you solve that, you would say, oh, it's -1. And that's the number that we put over here. And now we do the method for synthetic division. And the method is the first term you just add down. So 1 plus nothing is 1. Then you multiply by that -1, or whatever that number is that's in that position, which gives you -1. Add that together and you get 10. Multiply by -1 again, you get -10. Add that together and you get 6. Multiply that by -1, you get -6. Add that together and you get -10. And that is not so pretty. What does that mean? Well, it means that we have a remainder. So it means that this equals, and watch for the signs here. They go down by 1 degree. So if it was started with a cube, now we have squared plus 10a plus that number minus 10. And this is the remainder, so it goes over the divisor. So the answer is a squared plus 10a plus 6 minus 10 over a plus 1. And that is the answer to that one. Pause if you need more time. I'm moving on. Number 10. Same thing, but maybe let's do a different method. So let's do long division. I like long division. It ends up being useful later on a little bit more when you're dealing with like slant asymptotes, oblique asymptotes, and you can get some, you want to get to the remainder. I suppose you could use other methods, but it's just a tried and true classic that I need to go over. I feel like I need to like show you how that's done. So give myself a little bit more room. Hopefully not too much room. And we're going to divide this by p minus 4. And the way that long division works is you only deal with the first terms on the division. So p cubed minus, divided by p is p squared. And once you had that first term, you multiply by the whole p minus 4 business. And that gives you p cubed minus 4p squared. And once you have that, you subtract it from what's above. I'll do like a little subtraction problem. P cubed minus p cubed is 0. I'm not going to worry about it. 5p squared minus negative, in other words, plus 4p squared is 9p squared. Then we bring down the next term, and then we start that process over again. 9p squared divided by p. Try to use a different color here. Let's see, this one should work. And that gives you 9p. Because again, I'm dividing 9p squared by that initial p right over here. And then, once we have that, multiply it. So 9p times p is 9p squared minus 36p. But, we're going to subtract this. And that means we add 36p. So 36p minus 35p, that's just p. And so we're left with p minus 12. And then we do that again one more time. P divided by p is 1. And then 1 times p minus 4 I'm running out of colors to use. I'll use blue again. 1 times p minus 4 is p minus 4, of course. I can scroll down a little bit. Subtract that from what's above, and you get minus 8 as your remainder. So what that means is that we have minus 8 over p minus 4 as our answer. So this right here is the result of that division. I hope that makes it clear, and I hope that was helpful. I recommend rewinding, looking up the methods for long division, and also comparing it to synthetic. And why don't you try? You can try another method, see if you get the same result. And there's always the area model one as well. But why don't you try that out and see how you do. Number 11. Now we're getting interesting. It says, write a polynomial function of least degree that has real coefficients, the following zeros, and a leading coefficient of 1. Okay. A polynomial of least degree that has the real coefficients following zeros. Okay. So if these are the zeros, it's simply x minus 4 times x plus 1 times x minus 2. And that would be it. That would be all you have to do. We don't need any more degrees. We don't need any coefficients. We're good. The only thing that, I asked my previous period, do I have to do this out? And they're like, do we have to do it out? I said, yes. Then they said, okay, then you do it out. Okay, so if I was to simplify this quickly, you can fast forward a little bit if this is boring to you. Then this here gives you x squared minus x minus 2. Whoops. Okay. And then if you multiply that, I suppose I could do a little area model. Here's x minus 4. And up here we have x squared minus x minus 2. And we're going to multiply these. And we're going to get x cubed. Then we get minus 4x squared. Then we get minus x squared. Then we get 4x. Then we get minus 2x. And then 8. So what does that mean? That means that this right here equals x cubed minus 5x squared. You see how it's minus 5x squared? Because there's a minus x squared and a minus 4x squared. And together they add up to minus 5x squared. So I'm looking at, if I can highlight that, this right here. Okay, that gave me minus 5x squared. And then this right here, 4x minus 2x, that gives me 2x. I might as well just leave that color. And then we have plus 8 at the end, and that's my answer. Whoop. Okay, you like that? Well, get ready for this one. So why don't you pause this video again, and please try to work this out, and see what errors you make. And as you watch me, every time I get you unstuck, pause the video and try the rest yourself again. So we have this. Seems pretty straightforward, right? So just as before, there's an x minus 1. Or, I mean, there's a simple number that you put with in the binomial, x minus that number. And then I'm sure you would probably think, well, then we just do x minus 2/5. But that's actually not what we do. 2/5 is the 0. But generally speaking, they prefer there to not be any fractions. And so what we can do instead is we can say 5x minus 2. And just make sure that 2/5 is in fact the 0 of that, and it is. And then you're probably thinking, well, x minus 3i. And I'm kind of okay with that. But whenever you have an imaginary number, so I is, of course, the imaginary number That's what takes you to imaginary land, where the unicorn centaur guy lives, and they have a frolicking good time. They come in pairs. 3i has to come with its conjugate, negative 3i. So actually, we know this has to be degree 4, because you can't just have 3i. You also have to have the negative. And so, if you will, you can say x minus 3i, but also x plus 3i. And what I actually told my previous period, I'll tell you the same thing. And why don't I do this? I'm going to multiply these two right here. So that's 5x squared minus 7x plus 2. That's those first two. Is what happens when you multiply these is you get x squared plus 3. And that's not the difference of squares, it's the sum of squares. Well, 3 is not really a square, but oh, 3, wow. Okay, sorry about that. That's better. Okay, so there's that, and then like my student said, you got to do it too, Mr. Schellenberg. You can't just make us do it. Fine. All right, here we go. Okay, just writing all these out. A little tedious and cumbersome, but not a problem. In fact, in order to be successful in math, you really have to embrace the tedious calculations, because there's no success without embracing those. And if this makes you feel like, I got to do all these multiplications, if you have that attitude, then it's not going to go well for you. You really have to enjoy it. I find it relaxing. I'm like, oh, I can just multiply these, and that's not so hard. It's relaxing. It's fun, and I found that it builds stamina. And building that mental stamina where you do a bunch of calculations for a long time, very important to being successful in math. So do not knock having to do all these things out. It really is important. Okay, so answer is, drum roll please, 5x to the 4th. I'm going to minus 7x cubed. There's only one cube. It's 47x squared. Minus 63x. Plus 18. And that, my friends, is the answer. The rest is in another video, so I recommend you look out for that. I hope you enjoyed this. I hope this was helpful to you. Please like, share, and subscribe, and buy my merch. Thank you.